Ma'am, you can start now.
Okay, thanks. A very good morning to one and all present here. This is Vidya welcoming you all to the third day of this 1 week short-term training program on research methodology. Today we have our eminent speaker, Dr.S.Prasanna Devi, Professor and Head of Department of Computer Science of SRM Institute of Science and Technology, Chennai. We also have with us Dr. S. Manivanan, Dean of Dr. MGR Educational Research Institute and convener of this program. So may I now call upon Dr. S. Manivanan to welcome the gathering.
Good morning, everyone. It gives me immense pleasure in welcoming you all for this third day of our STTP on research methodology organized by Faculty of Humanities and Sciences, Dr. MGR Educational and Research Institute, Chennai. And today, my first and foremost welcome goes to our chief guest, Dr. S. Prasanna Devi, Head of the Department, Computer Science, SRM Institute of Science and Technology, Vadapalani campus, Chennai. And I wholeheartedly welcome our beloved participants. Really, I'm impressed the way how you are showing your interest in terms of learning. I really appreciate that. And I welcome the other organizing secretaries of this program, Mrs. Vidya and Mr. Ganesh Babu, who are doing very good work in terms of conducting this program in a quality way. And of course, I wanted to touch a few words about Dr. Prasanna Devi. She is such a brilliant scholar who has done her BE, ME as well as PhD from College of Engineering Gindi. College of Engineering Gindi is a premier institute in Tamil Nadu. It is the first institute started in the 350 years back in the entire India itself. It's one of the oldest institute I can tell. Entering to College of Engineering Gindi needs one to be a topper of district or topper of state. I am really proud that our eminent speaker, Dr. Prasanna Devi, is the topper of her school, and she scored very good mark in the entrance exam. She secured the seat in College of Engineering Gindi, and really I am proud to have Dr. Prasanna Devi as speaker of today's session. Of course, she has done her ME as well as PhD from the same institute. And of course, I am really wanted to share one word with our beloved participant. She is the recipient of Young Scientist Fellowship from the Tamil Nadu State Science Council for pursuing her postdoctoral fellowship. She is the student of Dr. Narahari sir, who is the greatest great person in the field of computer science. He is at present chairman of CSA, Computer Science and Automation at IISc Bengaluru, such a premier institution. I am really proud to have one of the alumni from IISc will be handling session for our young scholars. Really, this is a proud moment for our participants also. Of course, she has done wonderful job. She is doing wonderful job for ISOI Society. ISOI stands for the ORSI, Operation Research Society of India. She is actually secretary for that team, and she is doing wonderful job associating with IIT and Gindi campus. She is connecting bridge between the both premier institutions. And of course, I wanted to thank her personally for accepting our invitation and to be part of this event and sharing her valuable knowledge and giving hands-on training and accepting for 2 sessions. That is the greatest thing. Minitab is a really wonderful software, and that is actually 15 days trial. Anybody can download, or you can recommend this software to your institute also to buy. This is one of the such a simplest software anybody can use. After listening to Dr. Prasanna's session, of course, I am guaranteeing most of our beloved participants can come out, do a lot of research things. Thank you, madam, for accepting our invitation. And I will get back to you at the end of 6th session. Thank you, Mrs. Vidya. You can continue your proceed.
Thank you. Now it's time to introduce our speaker of the day, Dr. S. Prasanna. Dr. S. Prasanna, HUD, Department of Computer Science, SRM Institute of Science and Technology, Chennai. She did her BE from College of Engineering, Anna University, Chennai, her ME, Systems in Engineering and Operations Research from College of Engineering, Anna University, Chennai, and her doctorate in Information and Communication Engineering, again from College of Engineering and University, Chennai. And she did her postdoctoral research under Tamil Nadu State Council's Young Scientist Fellowship from Indian Institute of Science from Bangalore. Her academic experience. She has an overall teaching and research experience of more than 12 years. She started as an associate professor and head in Apollo Engineering College. She was promoted as a professor and head in Apollo Engineering College. Then she worked as an associate professor and head in SRM Institute of Science and Technology. Currently, she is a professor and head in SRM Institute of Science and Technology. Her other professional experience is a management representative in ISO 9001 implementation at Apollo Engineering College, Chennai. She is a recognized supervisor in Anna University, VIT University, and Mangalore University. She is also an honorary secretary in Operations Research Society of India, Chennai chapter. Some of her awards and achievements. She received the Tamil Nadu Young Scientist Fellowship Award from the Tamil Nadu State Council for Science and Technology in 2015. She received Best Technical Paper Award in IEI Second International Conference. She received the Professor T.R. Nadation Endowment Award for securing highest in her NE degree. She also received the Payne Memorial Award for School Topper. She also designed and developed the website www.donatelifeindia.com to promote organ donation awareness. She also launched All India First Free GSM Mobile Newsletter Service for Newsmass. Dr. Prasanna has authored 2 textbooks on real-time systems and management data making tools for Mahatma Gandhi National Council for Rural Education funded by MHRD. She's extensively traveled around India and places abroad like Florida, Paris, Sweden, Switzerland, and Germany, participating in many international conferences. Her areas of interest: artificial intelligence, game theory, big data analytics, and machine learning. To her credits, she has 30 plus Scopus journal publications. She has a H index of 7 in Google Scholar and 5 in Scopus. On behalf of Dr. MGR Education and Research Institute, we really thank her for gracing us with her presence and wish her good luck for future endeavors. So may I now call upon Dr.S.Prasanna Devi. Please take over the session. Over to you, ma'am.
Yes, ma'am. Thank you, Vidya ma'am, for that wonderful presentation. Thank you, Dr. Manivannan sir, for inviting me for this webinar on data analytics. It's actually my great privilege to address 475 participants. Probably I should say during this pandemic, this is my first webinar addressing such a good gathering of 476 participants. I really thank you very much for the invite once again. And moving on to the session, I would like to present my screen. Can I?
Yes, ma'am.
Yes, sir. Good morning to dear participants. The agenda for the day, like the topic given to me, is problem solving and data analysis. Yes, sir.
That small
Yes, sir.
shape.
The topic given for today's session is problem solving and data analysis using Minitab. I'm also going to touch a little bit upon the Excel solver. So you have to know how you have to use both Minitab and Excel solver, right? So the agenda for the day, it includes we're going to touch upon these 4 topics. So predominantly regression, I'm going to cover both linear regression and multivariable regression. And coming to clustering, we are going to touch upon K-means clustering, classification, logistics regression. And under time series analysis, we are going to focus on the simple moving average. So I should say one thing, like out of these 4 topics, the assignments will be given on all the 4 topics. Probably you can choose to select 2 or 3 assignments at least and submit it by the end of the day. As Dr. Manivannan said, the best participants will be selected based on your presentations. I mean, how you're going to work out the the problems and then give me the solution. Just a screenshot of it is enough. So moving on, I'll just revisit the certain basics that were touched upon by the experts for the last 2 days. So first I'll start with certain basics which we have to know. So I should say that we are going to deal with quantitative data analytics, right? So yesterday's speaker would have told you about 2 types. One is qualitative data analytics and the quantitative data analytics. So when I say quantitative data analytics, again, I can classify it as 2 types. One is the basic statistics, which covers the mean, standard deviation, variance. All these will be the frequencies, count, and all will be the basic statistics. So we'll now see how Minitab is going to handle all these basic statistics. I assume that the participants over here has the basic knowledge of all these basic statistics. So I'll just show you using Minitab how we can do these basic statistics, and then move on to the topics discussed in the agenda pattern. So I'll just open the, for the participants who are new to Minitab, I want you to go to Google, and you can download Minitab and install it. It's available as a trial version, and the trial period is for 30 days, right? So once you install it, this will be your main screen. So probably I'll just show you how we are going to do this part of basic statistics, right? So given a set of data, how do we calculate all the basic statistics, right? So that is my first question. So I'll just say that, okay, since these are in the horizontal tab, I'll just convert it into vertical tab here. I'll just take 2 minutes. Okay. Now, otherwise I'll take one thing. I'll just show you the example. So this is called as worksheet. What I'm working here is called as the worksheet. So using the worksheets, this is where you have to enter the data or copy and paste the data, right? So once you have the data set with you, so the first topic, parallelly I'm doing the hands-on part. So first topic, what we want to revisit to certain basics is to calculate the mean and variance. So as I told you, the statistics part here. So you just go to statistics, the basic statistics. Under basic statistics, yesterday ma'am would have covered about the t-test, right? And then the normality test. All these are the basic tests that we are going to use for the qualitative data analytics. But then what we are focusing now is quantitative data analytics. So here we are going to deal only with the numbers. So when I say basic statistics, I'm just going to say display the descriptive statistics. So you have to just choose the variable for which the descriptive statistics has to be displayed. Okay. So now, what are all the descriptive statistics that you want? So you just click on the statistics tab. So here you can choose whatever descriptive statistics you want to find out. So here I can say that you have mean, standard error, standard deviation, variance. So all these are the descriptive statistics that I want. So for this data set, whatever I have, so if I just select it and then give OK, I'll be getting all the descriptive statistics. This is just the basic introduction for how do you calculate the descriptive statistics. So here I will have the mean, standard error, standard deviation, and variance. So this is the just a revisit to the certain basics, right? And moving on, so all these formulas, we are well aware of it. So what is mean, the average, and then the variance and standard deviation will be calculating from the given values of given set of values. So that is what I just want to emphasize here. Then moving on to the next slide over here. So I again want to revisit certain basics, which is classification of data. So when I say classification of data, so we have these set of classifications. Again, I believe the classification of data was also well covered by the speakers of previous sessions. So here I can say that the data types predominantly what we will be using in today's data analytics, right? So we are going to use only these 4, these are the predominant data types that we are going to use for today. So the first data type is categorical. That is, under categorical, you have the nominal and ordinal. And similarly, you will also have numerical. That is, under numerical, we are going to use interval and ratio. Right? So these data types, for you people, just for recalling what the speaker has given an explanation yesterday, I can give you a small example, just how you can correlate the classification of data. Right? So when I say categorical data, so categorical data, it is sorted into groups. Say for example, okay, I'll take a small example. Probably all the four data types can be explained in that similar example itself. So when I say you have 4 people running in an athletic competition, 4 people from 4 different states or 4 athletes, okay, and at the end of the competition, all the 4 people will be coming as, I mean, three people will select them as winner, runner-up 1 and runner-up 2. Okay, so this is the selection procedure. And then on what basis the whoever the judges, they'll be asked to give some performance metrics for each of the athletes. So that is the third thing that you have to remember. And then finally, what you have to remember is finally once the running time will be calculated for each athlete. And once the running time is calculated, that is also a type of data. So out of these 4 types of data, so now what are the data that we have in hand? So the first data is the number given to each of the participants. Say for example, that number is given in their uniform. So uniform will say 1, which means the first person. 2, that is the second person. 3, that is the third person, and 4. So this will be the uniform number. So that is one kind of data. So that one kind of data, you can correlate it here. So that is going to be called as the nominal data. So when I say the nominal data, it is under categorical data. So here you can see in my slide, you have the categorical data called as the qualitative data. And the numbers, the one with the quantitative data is the ratio and interval data sets. So those people who has the uniform and the numbers written on it, they are called as the nominal data. So once you have the nominal data, then moving on to the ordinal data. Ordinal data says ranking. That is, once the competition is over, the person who came first is the winner. So that will be called as 1 again. And then the person who came second is called as a runner-up. That is given the number 2. So again, there you have a rank and an order and a scale. So that data is called as your ordinal data. And once the competition is, that is all for the selecting the runners. And coming to the interval data. So when I say interval data, so it says that no true zero is available, but then the difference between measurements is possible. What does it mean? So for example, how do I calculate this? So the same example of athletes running behind. So the person who came first is the first person, and the parameters by which the athlete is evaluated, right? So based on the performance evaluated by the judge, the 4 athletes will be given a ranking, right? So from 1 to 10 scale, probably you can evaluate the ranking. So that particular kind of a ranking given by the judges based on some parameters that were evaluated, so that can be taken as an interval data, right? And finally, you have the ratio data. So ratio data, I can say that the running time for each and every athlete, that is called as a ratio data. So when I say ratio data, there's a small difference in the quantitative data. Ratio data holds a true zero, which means a zero is possible. Whereas in interval data, 0 is not at all possible. So this difference you have to keep in mind. So we'll see certain other data, examples of data, so that you can easily recall the classification of data once I give you the data set. Right? So this is the prerequisite that we have to know, that there are 4 different types of data sets, and we have to fit in our each and every individual data so that we get a final output as we desire. Right? I'll give you a few more examples for the classification of data sets. So when I say rating of superior, based on above average, average, below average, and poor. So for this will be called as what it's called as an ordinal data. Why ordinal data? Because it is categorical. And as I've given here, the ranking and ordering, there is some way of evaluating the person based on which the rating is given as superior or above average and so on. And then ratio. What is this? Time taken by athletes to complete a race. This is what I told you. Time taken by the athletes to time taken by the athletes to complete a race is called as a ratio. So when I say ratio, it can have zero. What does it mean? Zero. The person can remain in the same place also. That is also possible, right? So that is called as ratio. And then ordinal. Ordinal is what? Again, grouping. It's a categorical data wherein zip codes are grouped. So when I say 600007, some zip code is given. Under this zip code, there is a grouping possible. So all areas belonging to this zip code will be, Parshvakam, Kilpak and all comes under this zip code. So that would be a kind of ordinal data. And then the ratio is again the height of a certain team. So all the heights you have to compare, and that is going to be a ratio. So the weight, height and all, I can say that you can also include a true zero, which means what? Height can be zero or weight can be zero. Though practically this is not feasible, but then all these are part of ratio data type. And then interval. Interval, what did I say? I said that the zero is not possible here. So here it is again, this doesn't include a true zero, but then this is a quantitative data which has a difference between two measurements, but then the true zero is not included. That is what is called as an interval data. And the generic data types, again, what we consider is the discrete and the continuous. So I think most of you will be knowing what is discrete and continuous. So if you can count the number of entities that are present, then that is called as discrete. And probably if you cannot count the number of entities by hand or by any mechanism, then that's going to be called as continuous. So number of students present, absent, all these are discrete. So you can count it. Whereas time to complete an assignment, it's all measured, but it's not counted. So that would be called as a continuous data set. So if you are clear with all these four different data, types that are available, probably we'll move into the next topic. So the agenda, as I've told you, will now start with regression, which will be linear regression. Right? So first thing, what is linear regression and why should we use linear regression? Linear regression we predominantly use to fit the data model. When I say fit the data model, if we have a set of parameters, say for example, X, Y, and Z. So if we want, and the output variable, let me take it as O. If we want to find out whether there is any relationship between the input variables X, Y, and Z with the output variable O, right? In that case, we'll go for a regression model. This linear regression model, so as stated here, so you'll be forming a line of regression. How do you construct this line of regression? Based on the available data sets here given to you, and the data sets, data points will be categorical, which means what? You're going to divide it into independent variables and you're going to predict the dependent variable. That is, the expression will have both independent and dependent variable. Which expression I mean here is the line of regression. So this, how do we construct the line of regression is the next part of it. So here I can say the types of regression, what we're going to see here is simple linear regression and multiple linear regression. So here you have the linear regression for a single variable. What does the single variable mean here is you have the predicted output Y and the input X. So what is the relationship of this input variable, single input variable X on this output variable Y? That is what we're going to calculate. And what is this beta 0, beta 1 and epsilon? All these are nothing but these betas are called as coefficients, or we can call it as regression coefficients. And epsilon is the associated error associated with this prediction. Okay. So similarly, if you are extending this for multiple variables, instead of 1x here, I'm going to have multiple x starting from x1 to xp, and along with each x, I'm going to associate one beta coefficient. That's it. Now we'll see how to calculate the values of beta coefficients. So here, as we have seen in the previous slide, y is equal to beta naught plus beta 1x. So this expression we are going to consider. What is y? As given here, it's dependent variable. X is the independent variable. Beta naught and beta 1, they are regression coefficients. beta naught can also be called as the intercepts. Okay, and beta naught is the intercept, or we also call it as the bias. And beta 1 is nothing but the slope. Why should we calculate the slope? So here you can see from this line, we are going to find the fitted line. Okay, so for each and every line, once we calculate the slope is nothing but the intercept of y and x. So that will be called as beta 1 here, because we are having only one variable x. So if we have multiple variables, multiple beta values has to be calculated. So this is the simple expression that we have to remember as far as the linear regression is concerned. Then moving on to multiple linear regression again. So instead of, as I told you earlier, instead of one beta 1 x1, we are going to include multiple betas, each beta associated with its corresponding x values. So this is the small difference between linear and multiple linear regressions. So with this, we'll just move on to a simple problem. So here I have a problem statement. So the problem statement goes like this. So you have 5 randomly selected students. So the max aptitude test, math aptitude test is given, and the scores are given here, right? So the question says, what linear equation best predicts the statistics performance based on math aptitude scores? So you have to predict the statistical, score in statistics based on aptitude scores. So what would be x here? X is going to be the aptitude scores, and y is going to be the variable that you have to predict. So which is nothing but your statistical scores here. So if a student has made 80 on an aptitude test, what grade would you expect that particular student to make in statistics? So this question you're going to answer with the help of regression. So all that we have is only x and y. X is the independent variable and y is the dependent variable. So first, what are all the basic statistics that we have to calculate is, using Excel, I've calculated the sum to be this, and mean is 78 and 77. Okay, what is this xi minus x bar? So this column we have to calculate using Excel. So xi minus x bar is nothing but this xi. In each and every value you have to take and subtract it with x bar. So the x bar is 78. Okay, so if you have to subtract it. Next is what? 85 minus 78. So this is how you calculate this particular column. Next thing what you have to calculate is yi minus y bar. So why is that yi minus y bar? Again the same thing for the dependent variable we are going to calculate. So this is the first part. Then moving on, we have to take the square of the numbers that was calculated. So here you have xi minus x bar. Here you're going to square the values and you're going to take the sum. Similarly, square all these values and take the sum of the column values. So this is the second part that we have to do. Once you understand the math, I'll show you how you can do this in Minitab. It will be just a 1-minute solution. Okay. Then this is also found out. Now moving on to the calculation part of it. So what all we have now? We have xi minus x bar the whole square, yi minus y bar the whole square. The next value that you have to calculate is xi minus x bar and into yi minus y bar, which is nothing but the previous two columns you have to just take and multiply. So that is what is obtained here. Now moving on to the equation part. How do you calculate B1 and B0? Okay, so B1 says summation of xi minus x bar. So remember, we have already calculated all these values here. These are what? Nothing but the slope intercepts calculation. So xi minus x bar into yi minus y bar by sum of all the xi minus x bar the whole square. So that is for B1. Why I have chosen by xi minus x bar the whole square? Because only one x variable I have, and that x variable is associated with B1. Say for example, if I want to extend this for another variable, then I'll be using B2, and this x bar, this variable, the division denominator will be for that particular. There's one question. Please tell what are x and y. Sir, I think you didn't follow the question. So the problem statement here, I have chosen two things. That is, one is mathematics. Okay. Math aptitude test marks is given, and the second one says that the statistics has to be, statistical scores, grades in statistics has to be determined. So X is nothing but your independent variable and Y is your dependent variable, right? So when I say Y is a dependent variable, that is a variable that you have to predict. So here, what is a variable that I have to predict? It is nothing but what grade would you expect her to make in statistics. So statistics marks is going to be my Y. Okay. And aptitude test marks, which is already available, is going to be X. I'll give you a simple solution. When I say if I have another student, sixth student coming in, and if his marks is, say for example, 75, what would be the Y marks, right? So that is what has to be calculated. I hope now the problem statement is clear. So now to predict that Y, I have to calculate all this B0 and B1 and all. So what is this B1? B1 is the intercept for X1. So when I say X1, I have to use this particular expression, which is Xi minus X bar. X bar is nothing but the mean that was already calculated, into Yi minus Y bar. Where do I have all these? I have all these in my previous tables, right? So here I have all these tables, values that were calculated by the summation of Xi minus X bar the whole square. So once I apply this, so what is this Xi minus X bar into Yi minus Y bar? So I have the summation of all this, which is 470. That has to be divided by the summation of Xi minus X bar the whole square. Where did I have this? I have it here. So that is going to be 730, right? So here when I divide, I get B1 as 0.644. That's it. So once I have B1, now it's very easy for me to calculate the intercept B0, right? So what is B0? Using the slope equation, it's going to be Y bar minus B1 into X bar. This is the normal slope equation, right? So Y bar is what? Y bar I have here 77 minus B1 is already calculated into X bar. X bar is what? It's going to be the 78, the mean of all X. So once I apply this, I'm going to get B0 is equal to 26 point something. Okay. Now what is the regression equation? Going back, how do I calculate the regression equation is, it's going to be B0 plus, so what is B0? B0 is 26.768 plus B1 into X. What is B1? 0.644 into X. So this is going to be my regression equation. So having this regression equation, now I have to find out how this can be calculated. Now what was the problem statement we had earlier? Yeah, problem statement we had earlier was, if a student made an 80 on aptitude test, what grade would you expect her to make in statistics? This was a question given to you based on prediction. These are not the actual values, these are only predicted values. So here I have Y dash is equal to B0 plus B1x. Now the equation what we got earlier is 26.768 plus 0.644x. So this is the regression equation, or I can also say the fitted line equation. Okay. Now this X is what? X is 80. Aptitude test marks is 80. So that 80 I'm fitting into this X here. So what is this Y? Y is nothing but what grade you expect that student, or what mark you expect that student to get in statistics. So that statistics mark is going to be 78.288. So once I fit this 80 in this particular equation, I'll get the predicted mark of statistics. So this is how I go for creating a regression equation, and using the regression equation that was formed, how do I predict my output? So this is the simple linear regression which involves only one variable. So the same thing can be extended if I have multiple variables. So when I say multiple variables, this X will be X1, X2 and so on. So though all those variables will be called as independent variables, and the dependent variable, again I can predict only one particular variable, which is one Y. Okay. So moving on further, you have to find out for any kind of a regression equation or regression, multiple linear regression analysis, we have to conclude by finding something called as R squared value. So when I say R squared value, it is nothing but you have to find out the coefficient of determination. What is this coefficient of determination is? before going into the formulas. Formulas, it is easy and it's just you have to calculate the mean, standard deviation and use those values to embed into this particular R square formula. But what is the use of this R square formula? Say for example, if I have two discrete variables, so y is equal to b0 plus b1 x1, this equation, where I can say y as some dependent variable. So if y is a dependent variable and if I say x is an independent variable, I'm not calling it as a dependent variable, I call it as an independent variable. Now, if I just ask you a question, should one person be, okay, a person with a very high IQ, right? So if that particular person, so IQ will be an independent variable. Let me call it as x. And the y variable, let me say that he owns, he owns a very big house, probably, may or may not be true. So if there is a real correlation or not, that has to be predicted. It may be true or may not be true. How do you find out? Based on your data set. So you cannot generalize this statement. Say for example, based on the previous marks, all the students who gets 80 in the aptitude test will get a 78.28 for a statistics. No, this is not applicable at all. This is based purely on what data set you have given, right? So similarly, any prediction that you make and any correlation that you make between the independent and the dependent variables, so you have to make sure how good is your analysis. So to find out how good is your analysis, you have to use R square analysis, and this is nothing but finding the coefficient of determination. And how do you infer this particular value is, the higher the value of R squared, that much good is your explanation about the dependence between the two variables, like how you correlate the independent variable along with the dependent variable. So now I have 0.48. I cannot say these two are not at all dependent. I cannot say they are very highly correlated. Probably I can say that there is some level of relationship between the scores got by the aptitude score and the mathematics score. This is how I have to conclude. So going to the math part of it, I just say that 1 by n of xi, all these values we have already computed, right? Xi minus x bar the whole into yi minus y bar. So these y bars and x bars are nothing but average of x and average of y, and that divided by the standard deviation of x and standard deviation of y. So this is how you have to find out and take the square of the whole equation. So you'll be finding out the R square value, which is 0.48. How do you interpret this? 48% of the variation in statistics grades, that is the dependent variable, will be explained by the relationship to the aptitude scores. So I can say that these are not very much correlated, but to an extent they have some correlation. So this is how you have to conclude. So basically the math involved is you have to find out the average standard deviation, that is x bar, y bar here, and then the square of it you have to do, fit it into the equations to find out b0 and b1, and then finally you have to go for the constructing a fitted line, fitted regression line. Once you get the fitted regression line, you can use that for prediction of a particular output variable. So once you have predicted the output variable, you have to check whether your fitted line is good enough or it is not good. How do you find out whether there is a particular relationship between, if the relationship between the independent and dependent variables are good? It is by means of going for finding out the coefficient of determination. So what is finding out coefficient of determination? It simply means that higher the value of R squared, the analysis is, or you can say the relationship between the independent and dependent variables are good enough. So the same problem, we'll just work it out using Minitab software. So for those who have downloaded it, probably you can try it with me. I'll just open the Minitab and I'll copy the data set before that. I'll copy it from the table itself. We just copy along with the header. So I'll just copy the 5 data sets. So after copying, I open Minitab. I'll open a new sheet. So in this sheet, this is called as my worksheet, workplace. Otherwise, I'm just going to paste the data sets. paste is not working. One second. Is it working in Excel? Yeah, it is working. Why not in Minitab? Yeah, okay. So now I have the data sets with me. I have the independent variable and the dependent variable, right? So the analysis, as I've given here, for those here who are new to Minitab, after you download it, just install it. It will not take more than 5 minutes if you're practicing hands-on with me now. So what you have to do is you have to go to regression. See here, you can find start, you have to go, then regression. Under regression, you have to fit the regression model. So it's very easy. So within a matter of seconds, you're going to get the output. So start, I go, regression, and then under regression, I'm going to just say fit regression model. So here it will ask you for the response. What is the response here? So the response here is Y, right? That is your statistical marks. Yeah. And coming to the predictors. Here the predictors, I can say, look at this, Xi. So now I just want you to answer whether this Xi is categorical one or a quantitative. We have seen two different data types. Can I fit it under categorical or continuous predictor is the next question that you have to answer. So probably I don't have any categorical values here. These are just numbers. So I'm putting it into continuous predictors. Okay. Then probably if you want a graphical representation, you can go for histogram of residuals. Residual is nothing but once you calculate the actual and the predicted value, what is the difference between that is what is called as your residual graph. But for the beginners out there, you just you can give the response here and the continuous predictor values here. So once that is given, that's enough. You don't have to go for any other extra modifications. You just give OK. Now we'll see what the answer is. We have to know two things here. One is what is the R square value, which is very important for a regression. Only then we can use it. And the second thing that you have to know from the output here is you have to find out the Y expression for Y, which is nothing but the fitted linear regression value. Okay. Now here, based on all these analysis, probably we are just interested in knowing what is regression equation. Regression equation says 26.8 plus 0.644 xi. So we'll just go back and check whether we have got the same value by redoing it with Excel. Okay. So here the equation what we got was 26.768 plus 0.644x. 26, yeah. So the same regression equation we have got here. So that is one thing we have to know. Then the second one, what we have got using all the mathematics that we have done was calculating of R square values. So what is this R square value? This is nothing but 48.03 using Minitab. And using our normal Excel, what did we get? It is, yeah, 0.48. So it is in terms of percentage, it is 48.03. So these two are the important outputs that you have to know from the Minitab. Okay, then if you ask me what is this ANOVA and all, as you all know, ANOVA is nothing but it actually tells you how good the factors are correlated. So if you ask me, the value for p-value here is 0.194. There is one question from Mr. Manoj. Where is it? Yeah, Mr. Manoj, I actually lost your question. Probably I'll take it up later. One second. So I'll finish this.
Madam, is it possible to predict categorical variable?
Yeah, categorical variable is also possible. Yes, sir, that's possible.
Yes. Then another question is few architect research scholars are also attending. They say already Excel is useful for making graph regression, etc. Then what is the difference between this Minitab and the Excel? Just for a clarification.
Fine, fine. Okay, sir. So see, Excel is very easy. Probably any calculation that you want to do, you can do it in Excel. Only thing, you have to manually code all the formulas. Probably when we go to logistics regression, you'll know slightly it will be difficult if you're using the Excel solver to find out the values. I'll not say it's very difficult, but then it's a matter of time, extra time and the extra effort that you have to put in. But using the solver, I don't think it took more than 1 minute to get all the results. So this is the only basic difference, but you also have a trade-off. Trade-off in sense, when you go for Minitab, the trial version is available only for 30 days. Otherwise, you have to go for a licensed version. So always Excel you have to practically solve all the problems using Excel only if you are a beginner. Data, when you go on your career as a data scientist, probably you can use the tools or you can go for programming languages R or Python. So that is for the next level of people. But if you are a beginner, you have to start only with the Excel solvers. That is very easy. That will help you to understand the math behind it. That will help you to understand far better than using all these tools. Blindly, if you have taught you only about using this Minitab software, what did I do? I just pasted these two values. I could have told you this is independent variable X, this is dependent variable Y. You just have to go to start and then you have to fit the data model so that you get the regression equation here. This is very much possible, right? But then you'll not understand what are these coefficients, how did you get this coefficients? So behind this coefficient given by here, given in this output, you have so much of math behind it. So how do you understand all this? What is this B naught? What is this? This is B1. So all this has math behind it, which we have solved it using Excel, right? So similarly, R square also had so much of math behind it, right? So how do you interpret it? All this is also important to understand. So for the beginners out there, I suggest that you have to go for an Excel solver to do all this, then finally come back and solve it using your Minitab. Okay. So now coming to the, I think till this, the linear regression is very easy only, so nothing much to do about it. Only you have to find out the regression equation and find out the R square value, and you have to know how to interpret. So with this thoughts, we just move on to the to-do exercise. So when I say to-do exercise, I'm going to post this in my, this is already posted in my Google Classroom. So this would be the exercise for the day. Okay, now I have done this problem using Excel, that is also posted there. But then I want you to just use Minitab software. So you have the test scores and then the IQ and study hearts. These are the data sets given to you. So the question says, develop a least squares regression equation. So you have to develop a model to predict a test score. Answer is also given to you. So this is going to be your regression equation. Okay, and based on IQ and the number of hearts that the student studied. So what does it mean? So IQ and study hearts are nothing but your variables which are independent variables. Okay, and this test score is going to be your dependent variable. Okay, so the test score is your Y variable. So you just have to find out the equation that finds out the relationship between the these two X variables, X1, X2 and the Y variable. The answer is also given here. And coming to finding the R square value using Excel, I've got the value as 0.905. You have to just check whether you have got the same R square value and the regression equation using your Minitab software. Now, since I've used two independent variables here, I'm going to call this as a multiple linear regression model. That's it, right? So now for the assignment posting, I'll just share you the Google Classroom code once again. Probably I've shared it in the screen. Once again, I'll do it. So do you have that code, sir, which was shared in the chat box? Manivanan, sir, can you share the Google Classroom code for the participants? I've already shared it in the chat box.
Madam, it is not visible.
Okay, 1 second.
Just you have to select all participants, madam. In that chat, in that two column, you have to select all participants. Then only it will
Okay.
be visible to all.
Fine. Okay, sir.
Yes, that's all. That's all. That's all. It's available to all. Right. Actually, again, Vidya shared to all the panelists, so it must be for the.
So that's not me,
Wait,
sir.
wait.
It's one of the participants.
I have actually shared my screen here. I think you can see, right? This is my Google Classroom code 4RDD162. Hope everyone can see this now. Yes? Can we?
Yes, now it's visible.
Yeah, okay. Okay. Moving on to the next topic. I've also posted. I'll post it as an assignment after the session is over, right? Okay. Now moving on to the next topic. Logistics regression. Though this term has the word regression, this has got nothing to do with regression actually. It's actually a classification technique. So when I say classification technique, you're going to use it for categorizing the feature vectors into two or more classes, which simply means given a set of features, independent vectors, how do I classify it into two or more classes is going to be the classification, regression, logistics regression. Okay, how are we going to do that is very important. Now, looking into this, we know that linear model is of this kind, a blue color straight line. This is how we have fitted the linear model, a straight line with a slope of, the slopes were calculated, and this is how we have calculated it, right? Now, the same linear model, if I want you to convert it into a value of p is equal to 1 by, if I put this way, whatever the value you get here, okay, you can take a value of y is equal to 50, right? So I can show you by in a small example. Y is equal to, okay, I'll put here 50. So this was the value obtained using the linear regression. When I wanted to convert to be a logistics regression, see, I should make sure that the value should be always between 0 to 1 here. So since a value between 0 to 1, I'm going to use. So probably the participants are asking, why is this Google Classroom code? They've joined late, I think. Probably, sir, those questions can be taken at the end.
Yes. Let me give. Can you give me, madam, 1 minute? I will explain to them.
Okay. Yes, sir. Yes, sir.
Dear participant, for those who have joined late today, just I wanted to tell you one thing. As per our earlier announcement, we will be having one best participant award event going to be held today. That will be taken care by our session speaker, Dr. Prasanna Madam. She will be sharing her Google Classroom code, and of course, she will be giving some problem also. Once you solve that problem, we request you to post in that Google Classroom before today evening 6 o'clock, 6 p.m. of today. After, if you could submit, we can't take that. So within that, those who are doing the problem correctly will be given that award based on the score what they obtain. So this is for your kind information. Those who are interested in participating the contest can go for the submission. For others, I think it need not. It's for those who are really interested. For others, it's a regular program. Yes, please. Sorry for the interruption. You can continue.
Yes, sir. Okay. For the participants again, so I just have a linear value of 50. Let us assume y is equal to 50 here. And now I want this value to be converted to some value between 0 to 1. How do I do that? So I just use a simple logistic model which converts it. So I can say that p is equal to 1 by 1 plus e to the power of minus y. So this value I'm taking it as minus y. So here, just for the illustration's sake, e power minus y I have calculated, right? So here what should I do now? 1 by 1 plus e to the power of minus y. So I am calculating this particular value. So some value, whichever I take, I'm going to convert it to a value between 0 to 1. So this is the idea of converting the linear regression model. Actually, I'm not converting a linear model into a logistic model, but then just for the sake of understanding, how do you use this model, the same linear model here, e to the power of minus y, into a model that fits the value between zeros and 1. So that is the predominant interest here. Okay. Now, why should we go for logistics regression? That is my second question. Now, in classification cases, say for example, if you are given a very big data set and the data set is asking you to classify whether this is a banking statement, let us assume, whether there is a fraudulent access to the bank or there is no fraudulent access. The answer can be only two variables. That is, either it can be an yes or a no. Similarly, the value can also be something like say for example, you have been given with a breast cancer data set. The output can only be yes, the output is classified as a benign cancer or a malignant cancer, right? So that would be again a answer which is in two variables, right? So similarly, other data sets also you can have, which is going to classify the given data set into 0 or 1, yes or no, failure or success. So for all these kinds of data analysis problems, we have to go for logistics regression. Okay. So when I say logistics regression, again you have three types of logistics regression. The first one is binary logistic regression, which we'll be solving it today. Then multinomial, that can be extended, same as we did for binary linear model. Then that was extended for multivariable linear regression model. So similarly, we'll do for binary logistics regression and to detect two possible outcomes, 0 or 1. Similarly, multinomial logistic regression, that is that will not have any ordering, which means what? You can have any number of categories, it can classify it, but then you'll not have any ordering among the classifications. So that is veg, non-veg, vegan is the common example that you get. Then the third classification is ordinal logistics regression, which says that you have more than three categories, any number of categories, same as multinomial, but then you have some ordering. So when I say movie rating, it cannot be just like that 1 to 5. Under
Madam,
that,
please go for full screen, madam, please.
yeah, okay, sir. Under that rating, you have to have some kind of a strategy. So these are the three types of logistics regression. Now we'll start with binary logistic regression. Now to understand the math behind it, we'll just start with Z. What is this Z? Going back to linear regression model, the same linear regression equation fitting model, I have just used it here. Okay. Now V0 is again the intercept, V1 for the slope intercept for X1. So all these are the variables. Depending on how many ever variables you're going to use, that many X variables you have to add. And converting that Z into a function of Z, that is converting into a probability value, is nothing but you're going to use this particular expression, e to the power of Z by 1 plus e to the power of Z. That's all you have to remember. Don't worry about all these calculations. I'll tell you about all this when we solve it in actual Excel. Okay. And next one is, once we have this probability value, then we have to calculate something called as total log value. I'll show you with the example using Excel solver. Okay, now I'll just open a problem here. Before that, I'll show you the problem statement. So you have the problem statement given here, a data set, probably 20 values are given. So here I have to predict whether a person is probable for a heart attack or he's not probable for a second attack. Okay. So the independent variables what we have chosen here are treatment of anger and trait anxiety. Now, treatment of anger is again a categorical variable. So here it is either yes, 1 or 0, whether he's under the treatment of anger or whether he's not under the treatment of anger. Then the next variable that we are using is the X2 independent variable again, which is the trait anxiety. So using these two independent variables, I'm just going to predict whether the person is going to get a heart attack or whether he's not going to get, what is the probability that he'll have a heart attack? Okay, and we have to check whether it is actually validated or not. Okay, now moving on to my logistics regression model. Don't worry about all this math, it's actually very easy. Just focus on this data set. So this was the data set which I have copied from this Excel. Okay, just for the interest of time, I've just already copied it. I'll now teach you how we are going to calculate all these values. Okay, now this is the first equation that we have to choose. B naught. So this is one fitted, let us assume a fitted line that we have assumed. Here the values of B naught, B1 and B2 are initially assumed, right? B0, B1 and B2 are initially assumed. Later, as you solve the problem, or the solver will solve it for you, it will find out what are the actual values of B0, B1 and B2. We are here to find out the values. We are not going to use the equations and all. The solver is going to do it. Okay. So now B0, B1 and B2 is used. Now what is Z value? Z is nothing but B0. See the equation here you can see. Probably I will zoom it. Okay. So here you can see the expression here. So $H $3, which is nothing but, I'll click it. So here it is nothing but this value B0. As per the equation, it is B0 into X1. What is X1 here? X1 is the treatment for anger. Then trait anxiety. So that is the next value. B1. Sorry, B0 is a intercept. The B0 is a constant value plus this value, the next value 0.05 into 1 plus this 0.05, which is B2 into 70. So this is how I have to calculate the Z value, right? So once this is over, what is the next value I can go for? So here again, how do I calculate this 4.1? So it is simple. Again, it is 0.05 plus 0.05 into 1 plus 0.05 into 80. So this is how I calculate the Z value. So since I have this, I can just simply, the formula is already embedded. I just simply click here and paste it throughout so that all my values are throughout the same. It is the same equation. It is, we have got the same values. Okay. Now this is done. Next step. What is the next step here? We have to find out the P value. That is the probability of occurrence. What is P? P is nothing but e to the power of Z by 1 plus e to the power of Z. So e to the power of Z. What does it mean, e to the power of Z? Again, going back to the equation part. So how do I do it in Excel? E to the power of Z is nothing but exponent to the power of Z. Z value is here. Divided by 1 plus, see here, it is e to the power of Z. So 1 plus e to the power of Z value is 3.6. So this gives me the P value. So once I have for one particular cell, the same thing can be copied and pasted throughout. So you just have to give copy the cell, and throughout I just have to give a paste. So it has calculated the probability values. Now you can see that the probability ranges somewhere between 98%, probably the minimum probability of heart attack is 86%. So this is as far as this data set is concerned. Okay. Now this column is also done. Hope till this point everyone is somewhat clear. Okay. Next, moving on to the log loss function. This is also very easy. So coming to this equation, right? So what does this equation say? It's very easy again. It is y. What is y? It is the output here. So 1, it can either be 1 or it can be 0. So if it is 1, then probably this will be the only value, y into log of p. Okay, this part is going to be what? It is going to be 1 minus 1, which is going to be 0. So you will not calculate this part if the value of y is 1. Don't get confused. Based on y value, I'm just interpreting this expression. And if the value of y is 0, then what happens here? This part becomes 0 because it is 0 into log p. So this part will become 0. And here it is going to be 1 minus 0. So here again, it's going to be only log of 1 minus p. That's all. So this is going to be my calculation for log loss. So this value I'm going to calculate it here. So I'll just click it here. Okay. So please don't worry about the Google Classroom code. Probably during the break, we'll just share the information again about joining the Google Classroom and all. You can have, you can just listen to the session now. Okay, coming to the log loss function, what was a value we had said? It is the y value. So here it says A2. What is A2? A2 is y value into log. Here the log means natural log. Here you can see from the values, n is the number of observations. Here the total number of observations here is 20. M is the number of possible class labels. What is M here? M is only 2 class labels we have because it's binary logistic regression. So it's either 1 or 0. Then logs is nothing but natural logarithm has to be used. So when I say natural logarithm, here I have to use ln, okay, in Excel. And similarly, y is the binary predictor. So either y can be 0 or 1. Why do I call it as a binary predictor? Because that is my output. The output can take only 2 values, 0 and 1. Because this is binary logistics regression. Now I think, and P is what? The model's predicted probability, which we have already calculated, that we are just going to use it here. Now I think all these variables are familiar for you, and these terminologies, these expressions are going to be just used in this calculation of log loss value. Now, what is this log loss? For a logistics regression analysis, this loss, whatever happens, has to be very minimum. Only then, as minimum, the log loss value goes down, then your prediction accuracy will improve. To improve your prediction accuracy, you're calculating the log loss value. Very simple. You just have to understand only this particular statement. Okay, now going to the calculation part. So it says minus of. So minus, now I'm not putting it here. I'm calculating it overall log loss here. So you are going to take it as y into log of p. What is that y into log of p? So y is here. Log of p is natural log of p. P value is this particular value. Plus 1 minus y. 1 minus a2. Again I've put this into natural log of 1 minus p. So this expression I've calculated it here. So once this is done, that is it. So log loss is calculated. So I just have to copy this here and I have to give it for all the values for which I have calculated the log loss. So once this is done, that's all. Now the final step here, actually this expression is for calculating the total log loss. So for calculating the total log loss, how I should proceed is I have to just calculate the sum of all this with a negative sign here. Here I didn't use negative sign. Kindly note, I don't have a minus sign here. So here for log loss, I just use minus of.
Ma'am?
Yes, ma'am?
I'm sorry to interrupt. Can we discuss for a break?
5 minutes.
For 10 minutes?
Finish this. I'll just finish this.
Okay, ma'am. Sure. Sure.
Thank you, ma'am. So here it is minus of, I can just see minus of 1 by 20. I'm just calculating 1 by n of the total sum of log loss. So that would be my log loss total. So once this step is clear for all of you, now the equation becomes very easy. Once again, z. Okay. So z value is this expression, so which is b0 plus b1 x1 plus b2 x2. Here, this is going to be called as x1. Treatment of anger, I'm going to call it as x1. Okay. And trait anxiety, I'm going to call it as x2. Right? So probably. And this is going to be my y. What is this? Y value, it is nothing but the second heart attack, whether it has come or not. So that is going to be my y value. Okay. So hope now I'm clear. Okay. Now just substituting this x1 and x2, b0, b1 and b2, I've just assumed it. Okay. So these assumed values I've just substituted here and have calculated the z value. b0 plus b1 x1 plus b2 x2. So that is how we have calculated z. And to calculate probability, what should I do is, I have to go for this expression, e to the power of z by 1 plus e to the power of z. So that would be the value for calculating the probability. So once that is done, so here again I can show you using z value, e to the power of z by 1 plus e to the power of z. That's all. Probability is, that's it. And log loss is y into, what is y? This is y into log of p. So log of p means I'm using log of natural log of this p plus 1 minus y, again 1 minus this y into natural log of p. That's all is log loss value. So once these values are calculated, I'm going to calculate the log loss total. This log loss total is nothing but minus of 1 by n. 1 by n. N is nothing but the total number of data sets that I have into the sum of all these values. That's all. Now simply I have to form the, I have to find, these were assumed values. I recall again, these are the values that I assumed it, but these are not the actual values, right? So now what I should do here is, I have to just minimize it. So I'm going to go to data. I have to use my Excel solver. If you don't have your Excel solver installed, probably for others who are using this for the first time, what you can do is you can go to your options here and you have to enable the add-ins. You have to go in Excel, and in this add-ins, probably you have to, yeah, add-ins are enabled now. So here, this Excel solver has to be, yeah. So here you can find Excel solver add-in, so that if you give OK, it will be added to your Excel worksheet. That's it. So here you can say that you have to go to data, whether to check you're going to run the solver. So go to data, here you have solver, right? Click on the solver. So once you click on the solver, what you should do here is you have to set the objective function. So it's already clicked. So this is my objective function, which has to be minimized, because I told you earlier that my log loss total has to be minimized. So I just choose this minimize as my objective function. And how do I minimize it? By changing these values of B0, B1 and B2. So some magic is going to happen, which means what? The values of B0, B1 and B2, it's going to be changed by this particular solver, and it's going to give me a new solution for B0, B1, B2, and log loss is going to be minimized. So now I just say solve. So 1.33 was my earlier value, and now it is going to change it. It has been changed as 0.68. Okay, now I just give OK. So 1.33 was reduced to 0.68 by means of changing the values of B0, B1 and B2. So which means what? B2 is for X2. Trait anxiety alone has been calculated with some coefficient. So this would be my expression now. Okay, so what is my Z here? Z is B0, which is 0, plus B1 X1. So B1 is 0 into whatever values of X you have. It doesn't matter. Actually, when you deeply understand, you'll start knowing that this anger, treatment for anger doesn't have much impact on this prediction. And finally, please explain again using solver. So I'll do it during the break, please. I'll finish this and we'll allow participants to go for break. Okay. And finally, log loss total is the value that was minimized. Okay. Now, what is that I'm going to do from this? Now, once this log loss, the logistics regression part is actually solved now. Now, coming to the prediction part. Now, what is the equation that I got? I told you it is B0 plus. So it is B0. Okay, I'll give some values here. So now I am a new patient. Okay, a new patient. Now I have to predict whether I'll be getting heart attack or not. Now my treatment of anger, I say it is 1, which means I am under the treatment of anger. And I'm going to give some trait anxiety value as 78. Okay, now for this new patient, what would be the value of Z? So Z value is going to be, I just calculated. I just copy the same formula and paste it here. That's all. I'm not doing anything else. So this is for the new values. B0, 0 plus B1 X1. So B1 is 0 into X1 plus B2 is this value into X2. X2 is what? 78. So this is the new value. Again, I'm calculating the probability of heart attack. And finally, I'm calculating the log loss value. Okay. Now let this be in one side. Now coming to this probability part. This is very important. Say for example, I can fit this into any line. I can just say anything below 50% is 0. I mean, I'll not get heart attack. Anything above 50% is I may get heart attack. But if you're using this for a very crucial application, for example, for cancer prediction, if you say that the size of the cell, if it is more than 75 or 80% only, then that is a cancerous cell. In that case, you cannot set the threshold as 50%. Okay. So in that case, you have to set the probability value as, the threshold value as 75%. Right? So above 75, if I get the value, then those things are going to be called as the cancerous cells. And if I get less than 75, that is going to be called as so the user has to specify what should be the threshold probability. So here, let me say that the threshold probability maximum is 0.58. So I can set something like 0.56. Okay. If the value is 0.56, if the probability's value is more than 0.56, then the output is going to be it's going to be 1. Otherwise, it's going to be 0. Okay. So if I put it that way, then what is going to be my prediction? So that is what is my Z value. So this Z value is going to be, the probability of prediction is what I want to find out, which is 0.58, right? So this is how you calculate the logistics regression. And you have to find out, the most important thing you have to remember is find out the equation again. So the same equation and the log loss total has to be minimum. So how do you use this log loss total? Is calculating this is by means of your solver, Excel solver. That's it. So using this, we are going to find out the values of revised values of B0, B1 and B2. Immaterial of whatever values you have already chosen, I don't bother. The solver will give you the minimum values so that this is optimized. When I say this is optimized, here the optimization function uses minimization, right? So this is all about the logistics regression. Okay. So I think with this, we can break for a small break, and then we'll join back at 11:30. Is it, ma'am?
It's 11:20, ma'am. We'll join at 11:30 if you don't.
Yeah, fine. Okay, ma'am.
Thank you.
Madam,
You,
you need not to
participants.
sign out. Just you can mute your camera and
Yeah.
mic, madam. You need not to sign out.
Yes, okay, sir.
So participants will disperse for a short break.